Hey friends, it's Mr. Rogers, and I wanted to go over the endocrine system. This is actually something that it's not part of this chapter. It's part of the anatomy section that kind of happens later this year, but it fits here. And so I want to kind of like take a little break from cells and talk about the human body and go through some of these things. Um, the main idea here is we're going to go through and we're going to learn the hormones. We have a quiz next Wednesday on this, so I'll tell you exactly what you kind of need to know. Plus, there's a Google Doc um, that shows exactly what you need to know. So, for actually the notes for hormones, so endocrine system. Uh, so we just went through the signal transduction pathway. One of the big signals that your body uses is hormones to go through this process. And these hormones tell the cells what they need to do, what they need to produce. And it's a preset thing, obviously. A cell, when it knows it encounters testosterone, it knows it needs to do this one thing. But hormones are a big part of this process. And truly, there's three major parts of the hormonal system of communication, how we actually do it. Now, one of them is the most famous one, and that's number two, but there is three other ones. So first, there's the exocrine system. Exocrine is a hormone that's secreted outside the body, outside the body. And for humans, that's basically sweat. But for most organisms, it is also pheromones. Now, pheromones are quite interesting. They're tied to sexual reproduction. Most pheromones in animals, basically, let's say, opposite member of the opposite sex member of the species know that they're interested or they're ready to have um, sexual intercourse or whatever reproduction, and so pheromones are really big in the animal kingdom. And this is an exocrine thing. They're releasing hormones into the air. And obviously, when you release into the air, there's some things that you need to make sure it happens. One, that it actually gets into the air and it can stay in the air and it can flow. Two, that you produce a lot. Picture like Axe body spray. You got to spray a lot of it for it to move across the room. Obviously, Axe body spray moves really well. You guys have all been a seventh grader before. You've smelt the hallway in the middle school where one kid just sprays really quick and all of a sudden the whole hallway smells like Axe body spray. Some other pheromones are more local. They don't travel as well as that. But the idea is you need to be able to spread it in the wind and whatever. Humans, we have never proven pheromones in humans. People have tried so hard. There is so much research into this because if they could figure out pheromones for humans, that person's going to make $1 trillion because they can say, hey, you know, you're interested in this person, this is how the pheromones work, or we give you extra pheromones so they're interested in you. Like it's all subconscious. So thankfully we haven't been able to figure it out because that sounds like a nightmare in our society. But it's interesting that we haven't. Endocrine system's number two. That's a hormone that's secreted by a gland that enters your blood and it stays inside your body and it targets a certain part of your body. And so the examples here are insulin made by your pancreas and it goes to your cells and your other parts of your body to reduce the sugar level. Glycogen, which is the same idea, but it increases sugar level. ADH, oxytocin, you get the idea. It's any basically hormone you've ever heard of because they're almost always inside your body. Um, that's what they're doing. Okay, they're a hormone that has a target place in the body that goes to and does a certain thing. And then the last one is neurosecretory. So these are specialized neurons that can also secrete hormones. And these are parts of your brain. So your hypothalamus and your pituitary glands, they are nerve centers. They're actually nerve cells that are also able to produce hormones. They can send signals like a nerve can, or it can send a hormone out. And so it's slightly different. It can also send both. And so that kind of makes it go faster. So think about it this way. Those two glands have the ability to send a quick message as a nerve and then send a hormone to reinforce that. That takes a little bit longer to get there. Hormones take a while to work. You have to produce them. You have to release them. They have to go to the cell. The cell has to go through its response of reception and transduction, and then it actually does a cell response, and then it has to do that cell response, which takes time. So hormones take a while. Nerves happen fast. They send the signal right away and get the cell going on its job. So these two glands kind of do both or can do both. So there's two different kinds of hormones that we're going to talk about. There are steroid-based hormones, which are lipid-based because steroids are lipids, and there's peptide-based hormones. And if we remember back from macromolecules, peptide is a protein. Um, Basically, why you need to know these is one of them allows it to go inside the cell to go interact, and one of them has to go through the outside of the cell and go through a receptor. So steroid lipid-based hormones, because the fact they're a lipid, they can go through the phospholipid bilayer easily. They don't need to go through the reception point or anything like that. They just kind of go into the cell and then they start the cell response. So there's not any of the whole cascade effects or any of the transductions or receptions. This guy just like cuts in line and goes right to the cell response. So that's testosterone, estrogen, those type of thing in most cells. And then the peptide is a protein-based hormone. That's going to be a guy that is not able to get through the phospholipid bilayer, and he has to connect to a actual receptor and go through the whole process. So this guy takes longer, but it truly typically works better because it produces more and it hits more receptors and more cells. So this is the more common one when it has to go into or has to affect more cells. The steroid hormone is more common when it only has to affect very certain defined cells. Okay, when it only has to affect certain cells, it's usually lipid based. When it has to affect the whole body, it's usually peptide based. Sorry, this was hiding it, so I just want you guys to see. So protein, this follows the stereotypical signal transduction pathway. It's going to be usually a tyrosine kinase or a G protein maybe, and that goes through the actual cascade or the camp, depending. So these are just the looks of it, the picture. So we have the protein-based one here. We have the hormone molecule made, goes into the blood, goes to the cell it needs to go to, starts a receptor, does a signal transduction pathway, and makes a cell response. The lipid-based one, the steroid-based one, gets made, goes to blood, and just blitzes through and goes right to the cell response. Okay. So hormones are a big part of our homeostasis, and we're not going to talk too much about this because we already did, but I just want to bring it back. So hormones help us keep a balance. This could be negative balance or technically keep us out of balance, which is positive feedback, which is the next slide. But so with our sugar levels, if we have a high glucose level in our blood, we produce insulin. Insulin then tells the cell to lower the sugar levels in our blood, and it does that, and it brings it back to normal. If you have not enough sugar in your blood, you produce glycogen then, and that glycogen hormone tells our cells that we need to put more sugar into our blood. Positive feedbacks also happen. Oxytocin is the hormone that starts childbirth and keeps increasing to keep having contractions and pushing the baby out. So this is a positive feedback because it'll just keep increasing until the child is born. So there are some basic endocrine glands. I want you guys to really quick write these down in notes. These are the ones that we're really going to focus on. We have the hypothalamus, which produces hormones that regulate the pituitary. So the hypothalamus is kind of the main boss in charge, and he's going to affect the pituitary gland. And then the pituitary gland is almost legitimately we'll say the assistant to the regional manager. And he is second in charge, and he is going to be affecting all the other glands. So the hypothalamus is the king. He tells the pituitary gland how to run the body, and the pituitary gland kind of runs the body for the hypothalamus. And so pituitary gland, major gland that produces hormones that travel throughout the body. Good description of it. A thyroid gland that's in your neck that produces hormones that regulate your metabolism. And so if you have a thyroid issue, you usually have a metabolism issue. Some people do. It's more common than you would think. The pancreas, that's going to affect our sugar levels. That's its main job. So insulin and glycogen that we kind of talked about with negative feedback. Then we have the thymus gland, which actually produces T cells, which is super. It connects to what's going on nowadays. So your thymus is most working. It's working the best when you are very young, and as you age, it decreases and basically dies inside of you and stops working. And what T cells are is T cells are your immune response to things that you've never encountered before. Its job is to, whatever virus or bacteria gets in your body, when you're young, it's going to be the first time you've ever encountered it. T cells are a defense against that. As we age, we reduce T cells because very few things are actually new to us, and we use antibodies instead because it flags the things that we've had before, and it says, "Hey, this has been here before. Kill this. This is a bad guy." Um, this is connected to COVID. This is one of the reasons. This is the number one theory right now of why young people don't struggle with COVID as much as older people. Is because COVID is new to all of us. So therefore, young people have more T cells, which is designed to kill off new things, and so therefore they don't get as sick. So really, in my household, I'm 65 years old. My daughter is 6 months old. She's probably going to be fine if she got COVID. She has so many T cells. Her body's ready for new things coming into her body that could get them sick. My body isn't, and so um, my body's based on antibodies, not T cells. So kind of a COVID connection there. Adrenal glands, that's going to produce adrenaline, norepinephrine, things like that, epinephrine, and those are basically adrenaline, if you wanted to know. And that's going to control your fight or flight response. That's why you get butterflies in your stomach, is because it comes from your adrenal glands, which are above your kidney, and it slows your digestion down, and that's what makes your stomach feel queasy when you have an adrenaline rush. And then we have ovaries and testes. Everyone's, uh, you know, it's like your health class, but not really your health class here. So your ovaries are in girls, testes are in boys. If you need to know more, you can ask your parents or your health teacher. But ovaries are producing female sex hormones, testes are producing male sex hormones. And so we're to the chart here. And so really just this page and this page, you can pause it, or I have it on the Google Doc, which is the next thing on the agenda for the day. But these are things that we are going to learn. So next couple of days, we're going to practice these and make sure we know them. What we need to know is three things. We have to know the gland, what hormone it's making, and what it does. If you would like to learn the chemical class and the regulated by, you're more than welcome to, and I'll give you extra credit for knowing those. Okay? I'll give you extra credit for knowing those. But for the most part, we're doing gland, hormone, action. So we have two different sides here. I think it's, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 of these we have to learn. What gland they're from, what hormone, what the action is. So start working on some flashcards. It's a good way of doing it. I'll make a probably GIM kit this weekend to help you guys practice it as well, but I think flashcards are the way to go with this. But that's hormones. That's kind of what we're going to cover in class. We're going to talk a little bit more on Monday. We're going to go in depth a little bit on a couple of these. But for the most part, that's what we're going to be learning next couple of days. So please make sure that you guys study up on these for your quiz on Wednesday. All right, guys. Thank you for listening. Talk to you later.